And we back. So now we're going to do 9.2, which is finding arc measures. A central angle is an angle whose vertex is on the center of the circle. So if I say this is A, this is C, and this is B, we can say that the central angle is angle ACB. Because it goes ACB. With angles, we need 3 letters. We also have arcs. A minor arc is the interior of the central angle. So right here, it's a little arc, and it's inside of this central angle right here. And we name it using 2 letters. So this would be minor arc AB. So we write AB, use 2 letters, and draw a little arc around it. And if I put a point D right here, we also have major arcs. So we got minor and we got major. And a major arc is the exterior of the central angle and does not lie on the minor arc. So basically, it's everything else right here. And we are going to call that major arc ADB. Minor has 2 letters, major has 3 letters. And we also have a semicircle. So if I got a semicircle right here, a semicircle is an arc. We're going to call this A, this B, this D, and this C. A semicircle is an arc whose endpoints are on the diameter, so right here. And the measure, well, this is technically half of the circle. A circle is 360 degrees, so it's got to be 180 degrees. And we name it using 3 points. We'll say this is arc A, B, D. Draw a little arc above it. Let that dry for a second. Tyan, say hi, bud. Say hello to everybody. He was really playful like a minute ago. All right, let's talk about measures of arcs. It's not too bad. Got a circle. Got with the vertex of C. We'll have A. We'll have B. And we'll have D right here. So the measure of arcs, well, I have arc AB, so the measure of arc AB is actually equal to the central angle, ACB. And the converse is true. So the measure of angle ACB is equal to the measure of the arc it intercepts, AB. For arc addition, the measure of an arc formed by 2 adjacent arcs is the sum of the 2 arcs. So if I got a circle right here, it's circle P, we got C, we got A, and we got B. So the measure of arc ABC, this right here, we can split that up. We can say that is equal to the measure of arc AB plus the measure, that marker's dead, the measure of arc CB. So just like line segments, if we add them up, it's going to equal the whole. Two circles are congruent if they have congruent radii. Because if the radii's got to be the same, the radius is the same, that means the circles have to be the same, which means they are congruent. And two arcs are congruent arcs if they have the same measure. Just like with angles, if the angles have the same measure, then they got to be congruent. Same thing with arcs. So, let's see. We have BC, DC, AD, ABC, ACD, and EAC. So we got all these arcs, and if I draw a big circle, A, B, C, D, E, shoot. Okay, and this was F. So we're given that this is 70 degrees, and this is 45 degrees. So let's see. So if we know that this angle is 70 degrees, that means this arc is 70 degrees. And this is a minor arc because it's 3 letters and it's 70 degrees. This has got to be minor. This has got to be minor because they're all 2 letters. So let's see, DC right here, hey, we got a diameter right here, B to D. That means this whole thing has to be 180 degrees. So this right here has got to be 110 degrees. For AD, arc AD, let's see. AD. Well, I know this is a semicircle. If this is 45 degrees, this has got to be 45 degrees. This is a semicircle, so 180. 180 minus 110 minus 45, that's got to be 25 degrees. So this has got to be 25 degrees, and it's asking for arc AD. So AD 25 plus 45 is 75 degrees. And we also have a semicircle right here. So if this is 45 and this is 25, this is also 110 degrees. Or we can just think, hey, we got vertical angles, and we know that vertical angles have to be congruent to each other. So let's see, ABC. ABC, that's a semicircle. Semicircles are always 180 degrees. ACD, we add all those up. It's major. That's 3 letters, and 290 degrees. And measure of angle EAC, which is a major arc, is 205 degrees when we add them up. And we got to tell whether that arc AB is congruent to arc CD. So we got to explain why or why not. So pretty clear that these 2 arcs have the same measure, so they got to be congruent, right? Well, these 2 angles have to be the same as well, because they're vertical angles. And because the angles are congruent, that means the arcs have to be congruent. that is it for today's lesson. Please let me know if you have any questions. Titan, Cassie, say bye-bye.